uh, address, thinking that you people are with us. There are, what I can see is 33 or 35 people are there in this virtual meeting. So I expect nearly 40 people because it's saying something and 35 more.
Okay. Sir,
So
sir,
yeah,
we have 45 now connected, and
that's
they
right.
will
That's what I said.
this number reach up to the 90. In morning session, the total 90 participant was there.
Yeah, so it's a post lunch. People are sleeping now. Good. So today, in fact, I was thinking when I was being contacted to deliver a lecture on AI applications or a workshop on AI, I was wondering what I should do. Um, I had been working for AI for a very long time, and then I stopped. So in fact, one of my friends said, when the AI started coming back, you stopped. I said, it doesn't matter. Well, I can always revive it back. That's not a big problem. I can always do that. And it's a good thing that, well, if you ask somebody to deliver the lecture, so I compile the previous things, whatever we have done. But here I'm not going to talk about something which I am doing at present because, as I said, we I have been working earlier and stopped working right now. So prominently, if you talk about the electrical engineers, the thing what goes is more on neural network and fuzzy logic, and the neural network has come back again in a big way. Only difference is earlier we have got two layers, now it has got multi-layer. We used to call multi-layer perceptron model, but it used to be only two layers. And the thing what we used to do earlier was the backpropagation is now extended. And now they call it a convolutionary neural network. So, or in short, CNN. And the recurrent neural network, which was existent for a very long time and people have worked it, that is again back. The first which I did with my MTech student was character recognition. It was a handwritten character recognition using neural networks, and it had got a very good success. It used to recognize up to 90%. Well, the character which we used to write was from a single person, and the dimensions, whatever we did, was also limited to the constants that we have given. But then, well, this is an application to OCR, optical character recognition. That's what I'm talking about. But here we are all electrical engineers, and our job is to talk about the electrical engineering application. So let me go with some sharing of stuff which I have prepared for today's talk. So yeah, it's now present now. I'll say your entire screen. I'll say share, and then I'll click here, and I'll say F5. Am I audible?
Yes, sir. Yes, sir.
Yeah, something went wrong. It has came out. All right, let me again try it. Present now your entire screen. Share it. I have gone here.
Yes, sir. Now it's
Yeah,
yeah.
it's F5. Hopefully, it's visible to you.
Yes, sir. Yes, sir.
All right. So we are today here to talk about the applications of AI in electrical engineering. And as I said, I can talk about the overview. My experiences are more on image processing. The other experience with the fuzzy logic was a recent MTech which I supervised to um one of the student who was from Banastali. He have been assigned because they don't do the thesis in Banastali. So they do the coursework, and then the students they go all across the country and they find out some supervisor, and then that has to be done. So she worked for facial recognition, and what we did was a type 2 fuzzy system. We published some papers also. So that is my experience of again the image processing application of AI, which we did it. Now that same girl is now doing PhD. But now she is working on signal processing, and precisely it is the speech. Uh, so stuttering is one of the problem जो आदमी हकलाता है. तो how do you recognize? I'm seeing uh, the response of if I you take the input of a stuttering person, and you can get the signature of the moment when the brain start misbehaving, and that gives rise to stuttering later on. So the idea is if you can make the speaker, the person with the stuttering problem, be aware that, well, you may be getting a stuttering phenomena coming up. And if it is being told, he or she can do a correction, and then probably his stuttering, that's the medical field, it's none of our business. So with this intent to predict the stuttering to take place, so audio signals we have taken from the Sanjay Gandhi Medical College, SGPGI, and it's a fuzzy domain again analysis, what she is working on. But that's a signal processing area. It's nothing to do with the electrical engineering. Uh, I have got some of my MTech students who have worked in fuzzy logic controllers. So, but it was 4 or 5 years back, or maybe even before this, where Sugeno Takagi model, TS model is called Takagi Sugeno model, has been taken, not the Mamdani. So, well, this is for the advanced users who are aware of this. Well, that's what precisely I also did in my PhD work. In fact, using TS model to control the converters. But in essence, I mean, this is an advanced user. I mean, when you talk about any problem in particular, then you become problem specific, and then you start actually more focusing on the techniques which is to be applied. And as a common interest, this is nothing which is going to interest any person, because you are not having the same problem what I can be discussing. So today what I thought of is something we should talk where everybody should have an interest. It should not be something which may be of interest to me and my problems which I can discuss my solutions. Sometimes it becomes very boring. I was attending one of the sliding mode control lecture by Bandyopadhyay from ID Bombay. And he went into some problem what he is doing with his PhD student, and it was in our institute only in NIT Allahabad, and it was so boring, so boring. People started sleeping, and then I mean we could not figure it out anything. So we just waited for the lecture to get over. Let us not make the things very very complicated for the क्लास में है. मैं बोला कोई भी नहीं आएगा, आप भी नहीं आएंगे, कोई भी नहीं आएगा, कुछ भी पेपर नहीं करूंगा. मैंने आपको भी बोला है, आप भी नहीं आएंगे. That's a problem when you are sitting in the dean's office and taking a lecture. Anybody can come and disturb you. The peon has come up with some paper to sign. All right, let's begin the lecture today. The keywords are AI and electrical engineering. So let's talk about. When I talk electrical engineering, the first thing comes up is a grid, and I'm always confused. At least I don't know English very good, so I keep referring to the Google and the dictionaries. So here I did a Google of grid, because right now it's a day of the smart grids. If you talk electrical engineering, the people talk about smart grids. So I thought let's talk from the grid, understand the grid, then a smart grid, and the smartness. What is a smartness? Is there any role of AI? Is it really relevant? So, and the distributed generation and all this stuff, what is presently the electrical engineers are fighting and trying to do something on that. So let's begin with the grid. And the meaning it says is a pattern of horizontal and vertical lines that cross each other to make a set of squares. A grid is also a system of wires through which electricity is connected to different parts of a region. A power grid, that's taken from the Google. And Google is also saying it's nothing his own or its own. It's from the Cambridge English Dictionary. I said, well, it's still confusing. Being engineer, I don't understand the language. So I went into further. Then I went into the Google image and saw the grid lines. That's your grid lines here. And that's what probably he's referring to, squares. And then I remembered, yeah, that's what we say when we go in MS Word or anywhere. This is the grid that we form. And it's also called a grid. And then I remembered the rationing holiday problem, which was there when I was doing my +2. Wondering, I did my +2 in 1982, 38 years back. But then seeing this and thinking, imagining there are resistors connected rather than the this was the first problem, where you used to have a ladder network of the resistances, and the algorithmic problem was find out the equivalent circuit of it. And I said, oh well, this was the first grid I have studied ever in my life. And then I realized, yeah, that is true. I mean, if you see the overall picture, when we say a power grid, as we studied, we got more confused. Power grid means something very big, some big wires, some D-STATCOM, some FAC devices, some this, some that, right? Some kind of big control. All right, it is all true. But fundamentally, what you have is interconnection. And what is there is, if I say smart grid, so I want to have the grid, the interconnection to be smart. I must know what are the interconnected. And then I was looking for some other diagram. I said, come on, this is too general. Let me look for, against, did a Google. And then I found this is some indiapowersector.com. From there, I got this diagram. And I feel, well, this is all electrical engineering. Is there a generating station? There is somewhere the customers who are getting the power from some distribution line. There is some substation there. From substation, we have got some lines which runs all across on the poles. And from poles, there are some cables coming to the premises, maybe a housing load or maybe some industrial load. It doesn't matter. And if I go and watch from outside a substation, I can see only a big transformer, huge, big one. And if I see the wires coming out, and if I take a motorcycle and run parallel to this, then it goes to all the fields on a huge big towers. And we also understand, anybody can understand, this is a transmission tower, and this is transmission wires. Only thing we never go up to this. So as electrical engineer, we know there is another transformer sitting at a generating station. So in fact, if you go to generating station, this all is a very huge area and nothing you can make it out. There's a huge amount of mechanical engineering which is involved for cold handling, and then the turbines, then the cooling plants, and so on and so forth. And the generator is sitting at a very small segment in the whole generating station. The only prominent thing what you can see if you go and take a visual look is again a substation where there is a huge big generating transformer. So there are two transformers, one at a generating station, another sitting at the substation, which is distributing. That's what makes the interconnection. And if that's only one, if I have got more substations, more stations, naturally we have got more and more interconnection on the transmission interconnection. And probably when we talk about the grid, what we mean is a kind of a ring structure which is getting formed by the different generating stations, or we have got a lot of IEEE bus standards which we are aware of as electrical engineers, and that's what you call it, a grid. Now something has come, a microgrid, and the derivative. But the first word which always try to make people, we have to understand, is the grid is a simply interconnection, nothing more than that. It's we're trying to do a connection. And connection is between a generating station and this. And what we are looking for is, I mean, this is running fine. We know it. There's nothing great in that. This is already in production. So people are producing, and we have got the revenue models, and so power system engineers, they are working on how do I maximize the revenue by variable pricing, deregulation, and other problems what people are working on, and try to get, this is all standard, it's already there. So you are doing kind of a derivative control. So is it not a smart? Well, first thing is, first we should know is what do we mean by smart? We have got smartphones. Now we heard of that some smart cities are going to come. We now know that smart bridges are going to come. We now know that smart houses are existing. So everything is getting smart. Well, what this smart is? So let's try to find it out. So again, I did a Google. I said, let me understand what is the meaning of a smart. And it says having or showing a high degree of mental ability, intelligent, bright, a smart young student, a smart decision, investment idea, and that's called the smartness. That's what he is defining. And the key word here is the mental ability. And mental ability is found only in living entity. So if I want to make a house to be smart, a city to be smart, this is a non-living identity. It doesn't have a life. I can call, there is a social life, that's a different story, but it doesn't have it's not an organic body where there exists a mind, where there exists a brain, a organic substance, which is capable of doing some kind of mental exercise and has got a mental ability. So what we can do is, probably we are looking for a machine to imitate the mind. And therefore, it cannot be called an intelligent one, because intelligence is a property of mind which lives in organic body, And that's why the intelligence what we impart to a non-living entity will be called a artificial intelligence. It's an intelligence which we are trying to impart. So here comes the AI. That's a key word which is now coined all across the globe. So what a human mind is doing and what we are trying to impart. So what we are saying is, if system can think like a human and if it can act like a human, then I'll call this to be intelligent. But when we say think like human, what does it mean? It means think rationally. When I say act like a human means act rationally. There should be rational behind every reasoning, and there should be a rationality behind every action. If we can impart this, we can call this to be a intelligent one. A simple machine takes an input, produces an output, and that's an output which is non-smart. But whereas if I take input, give it to the human brain, the mind, the output it produces is a smart one. So I had to model this to replace this. This can be modeled in two ways. One is the behavioral modeling or the psychological modeling. And another one is anatomical or going by the biology. So a psychological model is the reasoning what we do. It's nothing to do with the organics. We are not concerned whether the brain has got cells or it is just a mass of some protein. We are not concerned. How does the man behaves is of importance. So I can realize the intelligence through two different means: psychological modeling or anatomical modeling. And both of them is going to give me a smart output. And a smart output means intelligent output. And intelligent output means I have got the AI embedded in the machine. So do we have any measure? Yes, there are. And one of them is the Turing test 1950 by Alan Turing, who said, I can call this machine to be intelligent if it is going to replace a human who is answering behind a curtain to a unknown interrogator. And the interrogator is not able to differentiate between the human and the machine. If that is true, then the machine will be called an intelligent machine. And if I can do this completely, this is a complete intelligent machine. Else, what we want is at least by what factor this is close to, the machine is close to the human. So the end goal is to pass the Turing test. If you say it's a complete intelligent machine, it should be able to pass the Turing test. As simple as that. And what it really involves is there are four prominent things: knowledge, reasoning, language understanding, and learning. To be intelligent, I must have the knowledge. And that's why you are here. You want to create the knowledge about the AI application in electrical engineering. That's a very, very, uh, is knowledge data? And the answer is no. It's not. The data without meaning is not knowledge. So we need to know what this data actually implies and how it's going to be used. So a semantic understanding attached to the data, it doesn't make a knowledge. Reasoning, we know. Language understanding, we know. And the last segment is very, very important. You have come for a workshop, FDP, so you learn something, but then that's going to get old. And so you have to keep learning. Something new which you have to keep learning. And so you keep updating the knowledge, you keep updating the reasoning. Well, learning cannot be done without language understanding. So this is a prerequisite for learning. So if we have got a machine which can do at least these four elements, is as good as an intelligent machine. But mind it, when we're talking about this, it's a psychological or behavioral understanding of intelligence. So if I want to find out a person to be intelligent, why he is intelligent, so we can say that, well, these are some parameters by which we can say that, well, he has got a good knowledge, he has got a good reasoning, and he understands all the languages, and he keeps learning, and that's why he is intelligent. So this is what a psychological analysis gives us for an intelligent person, and so we want to go with some kind of algorithmic development on the data to acquire these property. And if I have got a program or a machine which running this program having these four characteristics, will be intelligent. It's a psychological mapping of intelligence to the machine. Maybe it's good or may not be. Some of the allied areas are search, vision, natural language processing, planning, learning. Some I have deliberately not said anything, like fuzzy logic. That's a diversion from here. Knowledge representation is a minimum thing, and a reversal search is a game theory what is being employed for development of the intelligence. Examples are playing chess, driving on the highway, mowing the lawn, answering questions, recognizing speech, diagnosing diseases, translating languages, data mining. While I know you are fully aware of, I am talking to the faculty, so I presume everybody is fully aware of. And now I say relax for a minute. Any suggestion or query before I further move ahead from here? Questions? वो जरूरी नहीं है कि लास्ट में पूछा जाए, हमने कहा बीच में
Any questions from participants?
I know you have taken lunch, you are feeling sleepy, and that's why I stopped in between. You don't go in a deep slumber or hibernation, so stop and ask.
Any questions from participant? Sir,
No, sir.
sir, please continue, sir.
Everybody is sleeping, let them sleep.
No, sir.
There are two things when nobody asks question. Either it's everything is clear or nothing is clear. So what do you want?
Actually, sir, we have received one questions in chat box by Abinya in Barmani. Can you please explain about smart meters?
All right, good. That's really appreciated. Somebody is asking something. This is something very, very interesting. Very good. Thank you for asking question. I'm really very happy. At least you are understanding something, or at least you have got a query related to something. As I was talking, that well, the smartness means intelligence, right? So if metering is for what? For charging money. So if I am the person who is lending the electricity, what I will like, or the customer who is going to pay what he will like, if we can do or cater to the needs of both of them, the one who is supplying, the one who is consuming, then I'm a smart one. So what the consumer wants to know is every day what is the consumption that I am consuming. If I can get a kind of a notional value what I have to pay at the end of the month, that is going to be good enough. As a supplier, what I want to know is what is the power factor that he is consuming, what is the maximum peak power that he is consuming, what is the worst or the offload condition, the minimum load that he is going to take, right? So based on this, I can plan, if not anything to the electrical network, but at least for my revenue. So if a meter which can do this is a smart meter. Now, the thing which is to be understood, can I get a smartness by analog way? The answer is no. Why I can't get it? Because analog things do not have any memory. Normally doesn't have. We have got the analog memory in form of the magnetic tapes, which is now obsolete. And intelligence needs a knowledge, as we discussed. Okay. So knowledge means data. Data means something which you are storing. So I need to have something which is to be stored. So the first thing is to be done is a smart meter has to be digital, number one. Now, if I say I must be able to know, or as a customer or as a utility, they should also try to know what's going on with this customer. So the second requirement is the communication. I should be able to communicate it. I must be digital, number one. Number two, I must be able to communicate. Number three, I should be able to take a decision. Now, to write with the data, if I want to take a decision, how can I do this? I need to run some algorithm. How can I do that? I need to have some microcontrollers who are sitting over there or some computer sitting over there. So if I say about a microcontroller, I have got a simple thing. There is a transducer which is converting all analog quantity into digital quantity, number one, because I cannot run away without in analog domain. Once you have a digital, you need to have a computational facility locally available. Now this you can achieve either through a microcontroller or FPGA. Number three, I should be able to communicate. So I should be able to communicate either through wire or wirelessly. If I am going for a wireless communication, that's fine enough. That's an area what is called the power line communication. Or if I want to go wireless, then the GSM technology or the other CDMA technology by which we are running our mobile phones, that is over there. Or I can go wireless 802.11, which is the wireless network which we are employing it. So what I am looking for is a system which has got ADC, a first a transducer, then I need to have the ADC. पहले आपने CTPT लगाया, उससे आपने करंट वोल्टेज नापा, उससे आप उसको लेके ADC करेंगे, एनालॉग टू डिजिटल करेंगे, then I need to compute the energy, that is V into I into cos phi into T. Right now, this is also going to be a algorithm which is computing this. So the energy that you have done is to be recorded with a timestamp. Well, another thing if I need to do is I need to have a real-time clock. So if I can do all these things together by some hardware, the hardware which results will be called a smart meter. As simple as that. You can utilize for whatever application that you are looking for. But if you understand what is smart, you can do it, achieve it. The application of a smartness can be used for whatever. Like mobile phones, I can be using it for Google Meet, which we are right now on, or I can have a phone call. So it depends on whatever use that I want to make it out of it. But I must have all the facility available with me if it is going to be a smart one. So the smart meter will need to have all this facility. Whatever that use that you want to make out of it, you can do that. I think is it clear? My answer, am I able to answer your question? What is a smart meter? क्वेश्चन पूछने वाले हैं या चले गए?
Yes, sir. Yes.
He is present, sir.
Have I answered your question, or you wanted to know something different and I answered something different?
No, sir, I have understood, sir. That's what I have replied in the chat box. I don't want to disturb that way. Sorry.
Okay.
I have understood. Thank you so much.
Great. So, in fact, I tell you, this is what we are doing. When we have taken a diversion from the main AI, so let me talk about some more smart concepts which are coming. Let's say when you talk a smart city, so what does it mean? I should be able to capture the data of the city. What is the population? What is the traffic? How does what is the hours in the business is taking place? Are the street lights are proper? Are the drainage system proper? Is the hygiene is maintained? So if you say a smart city has got some property. And the property which I am going to achieve is through only these things. So I need to have transducers. I need to have, or now the transducers are called sensors. You might have heard of a new term which is being coined very regularly, is the sensor networks. So I have got the sensors which are spread all across, and then we get all the data collected centrally, and an algorithm is running to find out the desired output, whatever we are looking for. For example, let's say I want to open a new outlet for selling some musical items. So I should know where the population is, and where the population is more going towards theater or some kind of other parameters which I need to uh, get from the city to assist me. If I want to build a house, a smart city, I should be able to know where are the sewer lines, where are the water lines which are coming, where am I going to get all this sunlight. So I mean, you can have these parameters which is readily available, and I can then make a decision out of it. Traffic, well, Google is doing a great job. I mean, we have everybody is now using Google Maps, where you get intelligent routing done. So while you are on the route, you keep knowing the traffic density at that moment of time, and then accordingly plan it. Should I go like this or that? So that's a smart cities concept. If I talk about a smart house, like we are sitting in a building, if I want to make the building to be smarter one, so what I expect, if there's nobody, the lights should be off, fans should be off, AC should be off, it should be locked. When it is a daytime, the windows should be open, natural light should come. So I mean, I need to accordingly find out the different sensors, the controllers, and as a rule of thumb, right now people are saying that, well, maybe another 10 years, your house may have 50 or 100 sensors, or the SIM cards, because you need to also have communication property. Everybody has to communicate. So these SIM cards, maybe 100, 200 SIM cards one house will be needing, where each device has to be connected. If you want to know whether the fan is running or not, I need to have a sensor sitting over to find out the fan's speed, or some kind of, at least the switch position, which is turning on and off the fan. Similarly, the lights, similarly the other transducers. So that's what is going to make the building to be smart. So if it's, I mean, you name the things, and it has to be realized using the sensors. The sensors means the transducers. So that's the broadly is the concept of the, and if I want to do that, if I have got multiple data, I have to play with the data. And let's come back to our presentation, where we talked about let's see, the first application is a search. We also talked about the last planning, learning. So the data once needed, so will be needing some technique, and if I have got any one of these techniques, what we call it is the intelligent one. So that's something what we are trying to achieve in our, not only in electrical market, but all across in the whole society. Why only the electricity market should be smart only? The civil engineering also is looking for the bridge monitoring, bridge health monitoring has to be smart. आपका ब्रिज टूटे नहीं, कहीं पे कोई क्रैक आ रहा हो तो मालूम चल जाए. हाई राइज बिल्डिंग्स हैं, उसकी हेल्थ मॉनिटरिंग होनी चाहिए. वाटर पाइपलाइंस हैं, वो भी स्मार्ट होनी चाहिए. कहीं पानी में कोई गंदगी तो नहीं आ रही, कहीं से कोई इनटेक तो नहीं आ रहा है. Something is not going to pollute the quality of water which we are drinking. So I mean, you apply the intelligence to any system and that becomes smart. And that's why the country is now asking to organize more and more FDPs and other kind of things to make the people aware that, well, you need to make all the systems, irrespective of the different branches of engineering or the sciences, to be intelligent. Right? All right, let's continue, because I am with some given time. I had to run away. I had to finish my lecture there. I don't know how many slides are there. Yeah, I am on 14 out of 39. Okay, shift F5 makes me to come here. Why we said relax is whatever we discussed right now is the logic which is called the Boolean logic. It's true, false, 1, 0. And through 1, 0, or the Boolean logic, we want to create intelligence in the machines. Gade in 1965 said, a German engineer, he said, oh, this is not going to be true. You can't get the intelligence really imparted through Boolean logic. Because a human never thinks in binary, 0 or 1. You ask somebody whether the guy who you met was tall or short, he will say, yeah, looks a bit taller, no? It can be called taller, slightly more than mid height. He will never say anything with affirmative. And if you, let's say, when you go and order something in your hotel or restaurant, you say, I think I can take 2 chapatis tonight and maybe half a cup of rice and something. You never say, I am going to consume 25 grams of rice, 10 grams of rotis, chapatis, 25 grams of vegetables, 10 grams of pulses. Have you ever said it? And we are said we are intelligent. So the logic went was, if you want to impart intelligence, you have to go, or you have to do away from the binary world. And the world which is non-binary is called the fuzzy logic, or fuzzy number system, or fuzzy arithmetic. It's a fuzzy world altogether. And it's not a world of zeros and one. It's not black and white. It's all gray. It's all the sets of white and black. Different sets of the black, or a combination of black and white. But then how do we quantify it? And the quantification was fuzzy membership functions and the values. So few things which came up is, man always thinks in linguistic. They always have got some word for each one of the things. And he always thinks in terms of some linguistic variable with some linguistic values. For example, we have taken a linguistic variable appetite, and the linguistic values are light, moderate, and heavy. So I may have a light appetite, a moderate appetite, or a heavy appetite, depending upon what is the value of calorific value of the food which we are consuming per day. So if I am consuming, let's say, 1,000 calories per day, I may be saying that, well, I have got light appetite. But let's say this is my version that I am taking a light appetite. The other guy can say, well, he takes moderately low value. So he is saying moderate and also saying low. Whereas My way of interpreting the appetite is, he takes a light appetite. He has got a light appetite where he consumes only 1,000 calories per day. There's third guy who says he has got a very, very low or very, very light appetite as compared to a heavy appetite person. So a heavy guy is also characterizing 1,000 at very, very low. He is not saying 0. So there are 3 different values, and all the three are saying something linguistically with a degree. So if I say light, somebody asks me how light, I say he's nearly 100% you can trade it. Almost 90% you can say he's a light appetite person. Whereas a moderate person will say, yeah, I know he takes light, but I think we can say 20%. So the membership or the grading value, that is a set where the gray values which changes. And we make all the decisions on membership value. Well, this is a complete engineering. A lot of work has been done. As I said, I have worked for fuzzy logic controller even in my PhD, as well as some image processing application for my masters also. In 1980s or 90s, people use this new branch of mathematics, fuzzy logic and fuzzy arithmetic, in a very, very big way. And thousands of papers are appearing all across. They never call it intelligent one, although they were working for intelligent systems. That's another beautiful part. They never coined it. And we'll be talking why they didn't call it intelligent system. Because not only the Turing test, which they were not testing it for, but there were other reasons also. So the Boolean people, they used to capture the knowledge through predicate values. So if there are some person who are here from computer science, they might be feeling, okay, ab hamara cheez aa gaya. Now we have got our stuff now. Predicate logic is there. So where we have got predicates like on, in, near, and all blah, blah, blah. And then we create a graph out of the objects, and this is called semantic, create a semantic networks, and graph theoretic analysis of the complete knowledge-based system. And then a derivative of it was the expert system, which started somewhere around 1970, and still it is going on. I mean, the expert system is not exhausted. Rather, in fact, still people are using expert-based system very extensively. And when you say expert-based system is if then else, nothing more than that. So if it's cloudy, then it's going to rain. Or if it is cloudy and it's humid, then if, again you say if, and if it is also windy, the chances of rain is this. Now that's the expert system. So you have a change of if then else. So if motorcycle, let's say an expert who is a motor mechanic, he will say, if motorcycle is turning on, and if the smoke coming out of the exhaust is normal, and if this is this, and if the mileage is low, then take out the carburetor, clean it. Else, open the spark plug and do something. That's what is called this expert-based system. So still we are using it, and a lot of expert-based system exists, and it's called an intelligent one. Right? There's one thing which I'm going to take for a moment is something written here. And now can I go back? Yeah, I could have used a different color for this. This is a very interesting thing. This is name of a programming language. Okay. Shift F5. Here is something written Prolog. Is one of the programming languages which has been used. It coexisted with another programming language called Lisp. There are two programming languages which have been in function for a very, very long time, starting from 1950s, 60s. It is a co-brother of Algol, and the commercial package called COBOL, you might have heard of. When I went to America, I got fed up with my electrical engineering, so I joined a software industry in America, and they were trying to develop some new program for Bank of America. And I was wondering why they are looking for. They said every program in the whole America, or this, in fact, the backbone is all in COBOL. And they want to now change it to C++ and Java. I'm talking 2004-5. So these programs are much celebrated programs which continued for a very, very long time. All the mainframes, they used to run these big codes. Now this is getting replaced. And now we have got a new programming language which has come. Since it's a course on AI, we need to talk about, because ultimately you need to do programming. So the program right now is in practice, or which is going to give a job to our students, is a new variant of Prolog and presently existing MATLAB, and the advantage of Java is called Python. And it's a time when we can do all these intelligent things on Python. So what is limiting in MATLAB? MATLAB was very good. We were all using it. So why we are departing? Why don't we continue with MATLAB? If somebody want to tell it, that will be good. Else I will tell you. What is the limiting value? Why the MATLAB is now stopping and getting Python in a big way? Nobody?
Python is an open source, sir, whereas in MATLAB is licensed one and we need to pay for that.
Okay, madam, you use Scilab then? Scilab is
we can integrate OpenCV in Python easily, while in MATLAB it is not easily integrable.
I was getting some parallel voice also. I could not hear you out.
In Python, we can use the OpenCV library very easily. In MATLAB, I don't know whether it is feasible or not.
You mean CV is computer vision. He is talking about computer vision. That is the open source computer vision programs are there. Well, it's something like elephant has got a lot of properties, and we are seeing one or the other. See, one of the biggest limitation of the MATLAB is we need to have a third-party software to go online. What I mean is, let's say you are designing a FLC, fuzzy logic controller, right? And you have got a converter, or you have got some electrical device which is to be controlled. Can you directly download the MATLAB code to your microcontroller or PC or any place to get it really translated into the hardware? And the answer is no. We can do a system level simulation. We can know what is going to be the behavior. Yeah, that's why we are able to test our new ideas using MATLAB. And then with this MATLAB validation, we are producing our research papers where the ideas are validated, and that's not a problem. The industries, they are asking, I mean, first you validate something. Once it is validated, it is of no use, because if I want to translate it, let's say I want to use my controller to sit on a ATmega microcontroller. Can I download? Answer is no. Now you have to take a ATmega third-party solution, integrate with MATLAB. Maybe it is directly compatible, then fine enough, and then I need to get a much more support. Whereas Python says, we have got a seamless solution. So a seamless solution for a real-time, even let's say, why to talk about the hardware? Let's say if I want to, I have got an application where I can do an image recognition, or let's say this computer vision he is talking about. So what I need to do is I want to host it on a web server. So you submit your images and I'll do some image processing and I'll give you a result, right? Maybe a medical image. So if I want to do this, I had to first write down my code on HTML or Java. Then my algorithm should be translated to Java or something. Then I had to put it all across on some server. I'm in trouble. So the idea is not getting translated. Python integrated. You can develop your web server, your HTML pages. You can write down your codes. You have got adequate libraries. Everything is over there, all integrated together. So I'm not going outside. Like in electrical, we normally go outside the computer because our world is outside world. We are not digital. We are all analog. We just want the digital world to help us in certain way. So there also we need something. And that's why, I think I made you understood why Python, or why there are so many jobs right now. If you talk about any person, any software industry, they are looking for Python people. It doesn't matter what graduation you have done it. They want the Python to be known to you. So it's a thing. What we have to do is, as we did it in 1990s. I tell you a simple incident. When I started my PhD, Professor Rindam Ghosh, my supervisor in IIT Kanpur, he came up and said, RK, I'll give you two floppies. One floppy of 1.5 MB, I'm saying. So this total is 3 MB, 2 floppies. That's a very good new program which has come up and you should try to learn it. I said, what this program is called? He said, it's now a new program called MATLAB. I said, come on, I want to learn Fortran. I want to go for EMTP. EMTP uses extensively the Fortran. So I want to do some coding in Fortran. He said, okay, you do with the Fortran, but also look for this. This is a new software package. And when I started using it, it has got the only advantage was when we used to do every coding in Fortran, we had to take out the data file and then go to some other. That time the Excel was also not that good. So we used to have some third-party graphic uh, design, or what we'll say, graphics packages used to be there to draw the graphs, right? I have forgotten the name. It's 92, 93 I'm talking about. But when MATLAB, it happened was everything, you did a simulation and the graph came. I said, come on, this is something wonderful. And the worst part was there is when in 94, the graphics was to the graphic workstations. It is not available, and we used to use normally these Windows came much more later. So the graphic workstation used to cost a lot, and people used to get some kind of scheduling done. Then in week you will get 3 hours or 5 hours of this. Even when the Windows 3.11, which we started working with, has come up with MATLAB and all these things, which has come up for Windows 3.11, it was something which was beyond our imagination, because to write on a paper, you need to have graphs drawn. So the integration of the softwares is a big challenge. And that was the time when I started talking about MATLAB. Professor Arindam Ghosh said me in IIT Kanpur, when I came to NIT Allahabad, I said to my colleagues, यार MATLAB बड़ा अच्छा है, MATLAB सीख लो, बड़ा काम आएगा, आज नहीं तो कल बड़ा हो जाएगा, ये बहुत अच्छा चल रहा है, इसका परफॉर्मेंस बड़ा अच्छा है. तो वही मैं अपने आप को देख रहा था कि आप आज 20-25 साल बाद फिर से नया पाइथन बोल रहा हूँ. तो अभी मैं आज 1-2 आपके FDP में बोल रहा हूँ, and tomorrow every electrical engineering seminars you will see Python, 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 right? So that's something which, because AI is supposed to come, because that's the future what we are going to do it. And so if you talk about the AI, it's going to be the Python's world. All right, I'm not going to talk about this. Let's talk about something, the neural networks. And the another area is evolutionary computing. That's something which is the present everybody is doing, every PhD is having some kind of GA or some kind of evolutionary algorithm for optimization. And when we say optimization and all this, we are trying to again imitate the intelligent behavior of human or the species to the machine that, or the program that we are developing. So I talked much more about that. I think I should go to the neural network because I am now probably running short of time. I'll be skipping this. I will straight away come to. I have skipped a lot, but not mind. There are a lot of other speakers, maybe better than me, who is going to talk. Because this is something which I started, and we talked only about the psychological paradigm. That is, we started with the predicate, knowledge representation, and then based on that expert system, and then we said, Jada came and he said, no more Boolean, forget it, come to fuzzy. So, but still it was the world of the expert system. If you are a user of fuzzy logic, you still apply the same kind of the inference engine, right? If error is small and error dot is large enough, then control is this, right? I hope you have done it. If not, somebody else will be talking about the fuzzy controllers and fuzzy based this. But it doesn't matter. This is actually either you go, if you are absolutely in the a Boolean domain, it's an export system. And when you make the variables no more a crisp value but a fuzzy value, then it's a fuzzy logic, right? But that's all the psychological modeling of intelligence or the mental behavior. The another approach what we said is the anatomical. So anatomy is open it up actually. So it's the other way of analyzing any problem, divide and conquer. So go at smaller and smaller scale. So we as a body, then we say it has got the different organs. The organs has got tissues. Tissues has got the cells. Cells has got the nucleus. Nucleus has got. So I mean, you keep dividing, and then this is what the anatomy is. That's the body which you're talking about. People thought when biology actually talks about this way of analyzing the whole biochemistry, and then they come up with different kind of conclusions and the biochemical reactions which gives rise to the medicines and all this. This is the medical sciences and the biological sciences. The another area was, can we, if you say that the intelligence is from the mind, so let us open up the brain and try to model it. And as we know, it's one of the models which came up was the neural network model. So a neuron is being basically, what we saw is that trillions and trillions of, not millions, not billions, trillions of neurons are there in the human brain, and they are connected. The number of connections are more than the number of stars in the skies. So that's the order of the interconnection that exists in human brain. And this, the interesting part was the interconnections are not well established at the time of the birth. As child grows up, so the gaps of the gaps which are in between the two interconnection start modifying, some increasing, some decreasing, and a matured person has got a adjusted architecture of the human cells, human brain cells in their brain. It has got the intelligence, it has got memory, it has got the different capability. As we know, the human brain and human, so it's all governed by the human brain. So earlier, that's what I was talking was, this is a model which was proposed long back, 1945, in a PhD work derived from neuroanatomy. And it successfully did a lot of good classification problem, and it was thought as one of the things which is going to impart intelligence to all the machines, and so we can formulate the problem. The issue came up in 1960s was by McCulloch and Pitts probably, or I don't remember who was the person who took a exclusive or a very simple problem and wanted to train the neural network for exclusive OR. And he wanted to make sure that whether the machine is trained and it gets an input, 2 or 3 inputs, and does a exclusive OR as an output. And this failed. And then it got stopped. And the moment it got stopped, the people said the AI is not going to come to the neural networks. And then this is being closed. And that's why when I was talking earlier, we said expert system was an intelligence system, but people were a bit reluctant because they saw the intelligent network was a neural network which has failed. So they didn't want to say this or coin this expert system as an intelligence system. Although its call is going to derive, you are going to get intelligence or derived from here. Now we are back to there was a single layer, so then the hidden layer was introduced. It has got capability. The problem we faced was as the interconnection went up, to validate some problem and to come up with the training of this network was challenging one. With the advent of high computational capability and decrease in the memory cost, we came up with a very, we can have any number of, now theoretically saying any number of hidden layers. And we know also, I have got another meeting, people started calling me. That's why I was jumping. Anyway, so this is the neural network which has come. मास्टर को पढ़ाने के लिए नहीं बोलना चाहिए, बहुत खूब पढ़ाता है. Right. This is one of the applications which is taken from one of the book where, well, what you can see here is if somebody hasn't used, I don't think there is anybody who is, they're all teachers, so I expect you have used this networks for these AI techniques in your problem. This is one of the paper which I've just taken as an example, again taken from Google book. I just thought, let me have some kind of picture where I can say you. This is a simple, you can see there is some converter, there are some filters over there. Something which we are not concerned with what this is doing is, but what you can see here, there is a neural network current loop controller. And it has got some inputs. This network is being trained to give these outputs so that it has got a complete closed loop system, whatever we are going to determine, whatever we have already trained with. As we can do it here, you can use either the neural network or the fuzzy or any AI technique, whichever you want. So this block can be replaced, or if I keep this block here, I can replace any problem. So the plant can be changed with the same controller, or controller can be changed with the same plant. So I can have the different AI controllers for the same plant, whatever is here, or I can have the same plant with a different kind of controller. The controller can be ANN based, it can be the fuzzy based, or it can be a simple expert system. It can be a combination of the two, neuro fuzzy, or it can be a derivative or a cascading of the conventional controller or conventional solution along with the intelligent solution. So this is what we are going to use actually in the in our electrical engineering. Again, I'm not saying anything particular about any. Now I have to hold you have to hold for a minute. Director is calling, my director. So I have to respond to him. Just hold on for a second. Sir, namaskar. एक सर लेक्चर ले रहा था, बस 5 मिनट में खत्म हो रहा है. मैं आपको कॉल करूँ 5 मिनट बाद में, आ जाए ना हो. सर. All right. Sorry for that. ये एक चीज तो है, ये आपको तो ये तो पता चल गया होगा कि डीन बनना नहीं चाहिए आदमी को, नहीं तो बड़ी दिक्कत होती है. यू कांट टॉक टू इवन टू स्टूडेंट्स for half an hour completely. Right, just joking. So here is another solution which we have is the fuzzy logic, fuzzy based controller. So some kind of converter, and so we take a feedback and do some kind of control action and give it to the converter. So in theory, this is going to happen irrespective of whatever you do. This converter can be used for your PV system for maximum power point tracking. It can be used for STATCOM to do a reactive power control or the active power filtering. You can think of, it's a very difficult task, that's what I said, to cover all the things together. In general, what we said is, this is how it's going to look. Again, it is taken from some random Google search. I don't want to talk any specific. That's why if you talk specific, then you get trapped into your problem. That's my philosophy of taking any class. नॉर्मली क्या होता है कि आप अपने पेपर ले लीजिए, मैं ले लेता स्टैटरिंग कंट्रोल, मैं उसमें घुस जाता सिग्नल प्रोसेसिंग पे, मैं चाहता नहीं हूँ कि वो आपको फंसाऊँ उसमें. कुछ लोग इसलिए भी नहीं बोलना चाहते हैं कि कहीं वो हमारा आइडिया आप चोरी करके पेपर ना छापे, आखिर हमारे ऐसी कोई इंटेंशन नहीं है. Anyway, so you have got the membership functions of some variables, whatever is there, and then normally the membership functions are triangular or trapezoidal. So this is a perfect triangular one. The variables are normally linguistic, like this is NS, negative small, 0, positive small, positive big, blah, 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 and something low, extreme low, good, high, extreme high, and so on. So, it can be these kind of, you have got different, like this is a load power, this is SOC, state of charge. And something, you take any damn variable of the electrical engineering and first fuzzify and then use it. And the defuzzification is, that's what I was talking, is the rule based. If something is something, then something is something. So if X is A and N is, then N is D. So if your input is this value, then I want output with this. But if input is this, then output is this. As we talked about, I can have 2 or 3 or 4 intersecting. So appetite can be, I can say, moderate, high, low, for the same 1000 calories, right? So one guy is saying this with this membership function, the another guy is saying another set with some other membership function, and third guy is saying something. And the 3 is going to give me 3 different outputs, right? And the question is, then what action I'm going to take? And the answer to this is, take a, there are various rules which is being taught. That's called a defuzzification, because the world is not fuzzy. When you come really, you think fuzzy, but the world is not fuzzy. Either my hands are moving or not moving. So that is always very sure. If my hands are moving, by what degree it is moving, by what velocity it is moving, it has got a value. So I need to go for a defuzzification. The crisp value has to be found. One of the simplest way is centroid. Get all of them and then take a centroid, and that's your defuzzification value. This is crisp value. And there are 2 which I have worked very extensively. Expert system is something which is which can be derived and you can do it. We can keep talking about the various techniques. AI has started again, and we need to remodel our problems so as to make it smart. So I thank all of you for a pleasantful listening, and I'm open to the questions, whatever you wish to ask. Thank you.
Sir, we have one question in chat box from Dr. S.K. Pandey, sir. In India, artificial intelligence is used in distribution level.
Oh, he's asking, is it being used? Okay. No, right now, no. Because intelligence needs a lot of data to be taken. Distribution automation is one of the things what has been taken and can be called a very low level of intelligence imparted. But truly saying it's not it actually. Distribution automation or SCADA is one of the ways in which you can say is a kind of intelligent realization of the distribution systems. But true smart distribution needs a lot of integration, and the sensor network has to develop. So the answer is again a gray one, not in true sense, but in a simpler way, it is yes.
Another question we have, sir, from Eswarya Narayan. Why membership function is mostly taken triangular in shape?
It's a very simple to take it. You can take complicated one. Actually, it's a very challenging thing. I mean, one thing is very sure is at certain value you are formally knowing. Let's say if I decide a 5'11" person to be tall, so if I have got a linguistic variable tall, at 5'11", the tall should have a membership value of 1. But if I go to, that's why, let me tell you, the type 2 fuzzy system is a offshoot of type 1. The one what we talk here is type 1 fuzzy system. Type 2 fuzzy system says the membership values are also fuzzy. So there is nothing called triangular. I mean, the triangular has got a slope fixed, but that slope is also fuzzy. So it is a range in which it is varying. So it's a kind of interval system which you are, the lines what you have drawn is not a simple line, but it is a interval system. So that's a type 2 fuzzy system where the people have started working in. Coming to the event, why to take triangular only? Why not trapezoidal or why not sigmoid? You can do that. It depends. And that's the area where you can experiment with taking the triangular. What is this? Is experimentation. This is your heuristics. Heuristics do not have a fixed rule, right? So it's a simpler one, and people have used it and normally found it to be correct. So people are happy they're using it. But there's nothing like why we should take triangular only. You can always vary from there.
Okay. Thank you, sir. One more question. Can we use AI for smart grid monitoring during peak hours of power consumption?
That is the use of the smartness. So if we can't use it for monitoring, then what else? Not only monitoring, we should also be able to use the control also. I mean, the load centers are Still, we are doing it with a human interference. We keep monitoring the peak hour loads and the load centers, they do it manually. The human interference is there to do the load management. And if we have got a machine replacing a human, then that should be doing the same business. We not only monitor but also control, depending upon the priority. Let's say if I have got less generations, so what I should do? Should the Bunde Meerut should be made dark or Delhi? So the choice goes, okay, let's put the Meerut on the darkness, right? So blackout Meerut. That's what the load centers they do it. So that monitoring and control is always done still today, but with human uh, interference or human operator. And that is where if you remove, that's a smart one. That's a smart, great.
Uh, Thank you, sir, for delivering an informative talk on artificial intelligence and its overview, covering so many things, fuzzy logics, AI and neural network. Sir have started his discussion with very simple explanation of electrical energy grid. Sir have focused on applications of artificial intelligence in electrical engineering. Sir, your talk will be definitely help to all the participants in their research area. Thank you, sir. And once again, thank you.
Thank you very much.
Thank you,
Jai
sir.
Hind.
Jai Hind, sir.
I'm now
With this-
disconnecting.
Okay, sir. Okay.
Thank you.
Thank you, sir. So tomorrow we will have our third session. The expert will be from IIT Kanpur, Professor Nishchal Verma, sir. So today we will share another link for the tomorrow session. Thank you all. Thank you.